We have about 2 lessons left in this chapter. So we're going to dive in more into the properties of logarithms and how you solve them. So we only did I think a couple properties when we condensed them and expanded them, where we talked about how addition becomes multiplication and subtraction becomes division. But we're going to talk about a few more today. So the question is, what are some other methods to simplify and to solve logarithmic equations or expressions? And when we do a couple of examples, hopefully you'll see where these properties come from, and then we'll just put the properties down one at a time and go through them each. So for our first example, we're just going to solve these like something we know how to do. Should be very familiar. It says you may need to change to exponential form. So the way I'm going to show you how to do these ones is by hand, is by just changing this to exponential form, where we cross out the log and we start with the base. You should already know how to do this. It's nothing new. Take the base 7, go across to the x, back around, equals 1. So the question is, what would you put in there to make it 1? And hopefully you can figure that out, that the only value that would work here is the value of 0. So you could also put this in the calculator and see that it would get 0, but we just want to practice going around the circle okay, so what would you plug in there to get 0? That would be, or to get 1 would be 0. And we're going to do it again. So we cross out the log, start with 4. 4 to the what power gives you 1? That again is going to be the number 0. And this thing keeps happening, right? We take this, take out the log, make 30, go across to the x equals 1. And so hopefully as you do these, you can maybe see a pattern that we're going to have here. So does it matter what kind of base we have? We started with 7, we did 4, we did 30. What about if we have any base, b? You do the same thing, right? B to the x power equals 1. The only way that happens is if x is 0. So in this particular case, it actually does not matter what the base is. It keeps changing. But what stays the same is that the number beside it is always 1. So once you see that big number here beside the base to be 1, you're always going to get the value of 0. So that's our first property. Logarithm of 1 theorem says for every positive base b, as long as b is not 1, remember we can't have that, the base of 1, log base b of 1 is equal to 0. So if you ever happen to see that with a 1 there, you can actually replace the entirety of the problem to just 0. All right, try another property. All right, so we're going to do this again. We're going to rewrite using exponential form. So we're going to cross the log, start with 4, go across, 4 to the x, go back around, equals this whole thing, 4 to the third. So this shouldn't be too difficult to figure out what number would have to go here to make them match to be the exact same. Well, this is 4 to the third. We need this one to be 4 to the third, so we'd have to say that x equals 3. And for the next one, same idea, cross out log, starting with our base 6, going across to the x, back around. This whole thing is 6 squared. All right, so we have 6 to the x equals 6 squared. What's the value of x have to be? Has to be the number 2. And lastly, 8, cross that log out, go around. 8 to the x equals 8 to the 7. Whoops. Back around. And so the value here would have to be obviously the number 7. So what's the pattern going on here? Well, looks like we have the same number matching here. We have the base number and the number next to it matching. And then we have an exponent here. So if we do have an exponent and these two numbers match, we can basically just say, okay, well, the answer is going to be whatever the exponent is. So in this particular case, we said 3 was the answer. And over here, we said 2 was the answer. And here we said 7 was the answer. So that's our next property. We're looking for those two numbers to match. And if that happens, we just basically look at the exponent for the answer. So log base b of b to the n theorem, for every positive base b not equal to 1, and any real number n, can have any real number as the exponent. Basically, what we're going to do is just say, okay, we can get rid of that and just say it equals the exponent, n. As long as these two things match, you can just change it to n. I think we have, how many more? Pretty much only one more property. And then we'll be solving these using these properties as well. Okay, example 3, expand the following logarithms and simplify. Okay, so I'm going to go ahead and break this apart. If you remember, when you see multiplication, you change it into addition. So this is going to be log of 1,000 plus log of x squared. This is going to be a new property, nothing we've seen before. So we don't have anything matching here. The base values here, if you don't see them, remember, is going to be 10. So let's see if we can simplify. This one I'm actually going to simplify the way it is. So if you think of this being a 10, right? 10 to what power gives you 1,000? That changes to the number 3. But what I'm going to show you is something a little different whenever you see an exponent here, is that I'm going to show you that you can rewrite this a little differently and then also break it apart again. So I'm going to go ahead and rewrite this as, instead of saying log of x squared, I'm going to write this as log of x times x. Now when you see two things being multiplied together, I'm going to break it apart like we did up here with multiplication. So I'm going to write this as log 3 plus log x plus another log x. And this itself can actually be simplified. I'm going the long way around. Hopefully you can see the pattern. But this can also be simplified into, well, you have one log x plus another log x. So we actually have a total of 2 of them. 2 log x plus 3. There we go. So what's going on here? How can we maybe go from this middle step, instead of writing all these multiple steps here, I'm kind of want to jump down to this, if you can see what's going on. And we also saw this before in the triangle activity that we did. Okay, so let's get rid of the number here. We're just going to have log base 9 of y to the third. If you understood the shortcut here, what's going on, I would do this one more time. I'm going to break this apart. Now, first off, let's just say it's going to be log base 9 of y times y times y. Because there's 3 of them, right? And I'm going to break this into multiple logs with pluses. So log base 9 of y plus another one, log base 9 of y plus one more. But what does that mean we actually have? We have 1, 2, 3 of the exact same thing. So we can kind of combine these all together and say we have 3 of them. 3 log base 9 of y's. So what's the shortcut? Hopefully you can figure it out by now. If you see something like this with an exponent, no matter the base, no matter what number you're talking about here, in this case a variable, what can you do with this exponent? You can basically just keep it what you have and then bring the exponent out front. Let me back this up a little bit. So you just take this 3 and we're going to move it out front. That gives you your answer. That's our next property. So if you see something like this, log base e of z to the fourth, I'm not going to write this out 4 times, obviously. First of all, notice that log base e is the same thing as, we can write this as this, ln of z to the fourth. And then by using this new property that we kind of discovered going through, we can just go ahead and throw that out front. So we can say this is 4 ln of z. And you could also go the other direction. If you see the 4 down here, you could also jump it up to the top, make it an exponent. So that's actually our next property. Logarithm of a power theorem. For every positive base b not equal to 1, and for any positive real number x and real number n. So if we ever see this, we can go ahead and just throw it out front. We can say it's n times log base b of x. So we're just taking it and putting it out front. All right, so let's try some of these. Now we're going to start condensing them, but we're going to have a number out front that we're going to have to probably then change to an exponent. So we only have 2 more examples left. I'll probably do some more that are in the huddle, though, as well. All right, so let's condense these. First we want to do is look at these numbers that are out front, which we only have 1 in this case. I'm going to go ahead and throw that up to the exponent. This is log of 5 squared. Let's copy the rest of it down. Now, most of this we already know how to do. I'm just putting extra logs out here. We kind of talked about this a little bit last week. So we're going to go ahead and put these two together, which, by the way, we could probably do 5 squared if we want. But when you see a plus sign between them, we're going to multiply. So I'm going to put those two together and just say it's log. This would be 25. So we're doing 25 times 6, which is 150. Minus log 3. Whoops. And then when you see subtraction, put them together. We know that that's division. So we're going to do 150 divided by 3. And I'll go a little bit step further here because we can do 150 divided by 3, right? That turns out to be just log of 50. And I would try to see if I could go further, but there's a 10 here, and you can't raise 10 to a power to get a nice number like 50. Okay, part B. Remember, we're going to take all of our front numbers, and we're going to put them up in the exponent. That's kind of the strategy, going back the other way. So we're going to take 3, we're going to put it up here, and we'll go ahead and evaluate what this is. This is log, what's 2 to the third? Right, 2 to the third. That is 2 times 2 times 2. I'm just going to replace that with the number 8. Plus log 7 minus log 1. Okay, so we have multiplication between these two. So we have log 8 times 7 is 56 minus log 1. And here we have division because there's subtraction between the two. So this would be 56 over 1. Well, does that really change anything? Nope, not at all. So it's still log 56, which you could also recognize. This was a property we looked at earlier. Let me go back here, log 1. No matter what the base you have here, doesn't matter what you do with the base. If you see a 1 in this spot, it's going to be the number 0. So let me back up. If I noticed this here, that this would just change to the number 0, then I would have log of 56 minus 0, right? Before I actually put it together and divided. So you can do it one of two ways, by noticing this and just getting rid of it. Like we didn't need it from the very beginning. We could have made the whole thing 0 there and just multiplied them together. But it doesn't really matter. We eventually get to the same answer. So log 56 minus 0 is still log 56. Okay, now we're going to be solving for k. And I'm just going to kind of go through all the steps of kind of what we know how to do and how do we do this in order. So what I would like us to do first is make the front numbers the exponents. So the ones in front of the logs. And there's a bunch of them here. We have a 2 here, 2 there, and a 2 there. So we have a bunch of squareds, right? We're going to change this to log of k squared. This one goes up, becomes log of 12 squared. Now this is a little tricky here whenever you see the 2 and a minus sign. I only want the number. I'll keep the minus sign there. I just want the number to come up. So log 2 squared. And this last one does not have a front number, so we'll keep that the same. And by the way, all these bases, to make it a little easier, I made them all 10. So we have to keep writing the base number. And then I'm probably going to solve these ones, these exponent ones, and do the next step. The next step would be combine all addition by multiplying together. We don't have any addition, so I'm just going to write my next step by just keeping this and changing it to what it equals. Log k squared. We can do log of 12 squared, that's 144, minus log of 4, minus log 9. Okay, so we actually don't have this one. This one's done. Combine all addition by multiplying. Then we're going to combine all subtraction, and this is the best way for me to think about it when you see subtraction, is we're going to multiply, combine all subtraction by multiplying, and then placing the answer in the denominator. Okay, so we're going to actually combine all three of these. I don't know what's going on there. Combine all three of these. We have log 144 And we're going to divide that by 4 times 9. We're going to multiply them together, get 36, and that will go on the bottom. I don't know why it's doing that. Then we have over here log of k squared. So we pretty much are good there. I'm probably going to simplify the 144 divided by 136 or 36. And then we'll see what we get. So we have log of k squared equals log of, if you divide them, you actually get the number 4. And now we're on our last step. So we did this. Cross off 1 log. Uh-oh. Well, that's supposed to say 1 log. It's really messed up. Let me see if I do this. Unlimited things, great. It's supposed to say cross off 1 log from each side to solve. So let's go ahead and do that, even though this is messing up quite a bit. So cross off a log from each side to solve this. We have k squared equals 4. So whenever you see this, you just have to cross off the logs. As long as you have 1 from each side, you can do that. Don't have to worry about doing the circle thing or anything like that. Now we have k squared equals 4, so we can solve that by getting rid of the k squared. The way you do that is doing square root. Get rid of squared. And square root of 4 would be plus or minus 2 if you've forgotten that you have to do plus or minus on those. I'm not sure why this keeps messing up. Yep. Interesting. Okay. That is actually the last example, unfortunately, but I'm going to try to I'd like to be able to figure out what's going on and why this is messing up. There are some harder ones for you to do as well. Quite a few of them. So just remember those steps that we tried to go over back here, where this whole thing started messing up. You make the front numbers the exponents. You combine all addition by doing multiplication. Even the subtraction ones, you kind of do multiplication, right? You put the subtraction ones together by multiplying them together, but then you put the answer in the denominator. That's why we put the 4 times 9. We got 36, but it went in the fraction at the bottom in the denominator. So I would try to do some more. I'm not sure if I'm able to do any more without this messing up. I can try to do another 1 or 2. Let me do one that might be a little bit more difficult. They don't look too terrible. Maybe I'll just do one more. I'll do something like C. So remember, if you see the numbers out in front, we're going to do them first. So I'm going to put them on top. So we're going to have log of 10 squared plus log of 2 to the third. There's another one here. Minus log of 4 squared. Now we have to put all these together. So with pluses, you multiply them together. It'll be log of, 100 times 8. Right? Is that right? It'd be 800. Minus log of 4 squared, which is 16. And then we put these two together, which is kind of like dividing it. 800 divided by 16. And if that comes out to be a nice number, then you would do it. If not, don't do it. Ends up being the same thing as log of 50. That would be your answer. Maybe do another one that has an equal sign in it. Okay, something like G. remember, these all have to have the same base, like as always. Nothing has changed here. We're going to do log of 60. That's multiplication. We have nothing out in front here, so we can keep that the same. We're on step 2 now. Put those together, you get log of 5a. Now we have the same log on both sides, cross them out. So we actually get 60 equals 5a. And then we can just divide both sides by 5 and finish it off. Whoops. So we get a equals 60 divided by 5 is 12. I'm going to stop there because I don't know what else is going on and why this keeps messing up, but you should be able to finish the rest from there. It's like maybe like 8 or 9 more to do. And that'll be finishing up 9.9. Only one more left.